Hello friends, in this video I am going to explain some important properties of vector addition. I have mentioned here properties of a vector addition. First one is the vector addition is commutative. Vector addition is commutative. It means you know that in general addition, suppose I am writing 5 plus 7, that is also equal to 7 plus 5. Here, order is not matter. 5 plus 7 is also equal to 7 plus 5. You know already in mathematics, addition of natural number is commutative. But here I am going to explain vector addition is commutative. See here how it is. For example, A and B are two vectors. So I can write A plus B also equal to B plus A. Let us see here. Suppose this is a point. At this point, two forces are acting. One in this direction, that is vector A. One in this direction, this is vector B. Let us see. At first A plus B. This is vector B. The vector A, I am shifting it parallelly. You know that there will be no change in shifting a vector in parallel. So the vector A, suppose I am taking it here. That means first vector I am taking B, second vector I am taking A. And here you see that the two vectors are arranged in a particular order. However, it is representing the two sides of a triangle. So I can apply the triangle law. So the resultant vector will be a vector from this point, from the tail of the first vector to the head of the second vector. Here B I have taken the first vector and A I have taken the second vector. That means this is the resultant vector which is equal to B plus A. Now you see here, suppose here now the vector A, I am considering this is the first vector. The vector B I am shifting here from here to here. That means now it is like this. This is the vector B. I am shifting it, this one from here to here. So now this is the first vector, this is the second vector. So the resultant vector will be, this one will be the resultant vector which is equal to A plus B. You observe that this one and this one same thing. So here this is A plus B, this is B plus A. That means A plus B is equal to B plus A. This is the vector addition is commutative. So here order is not matter. Whether you add B with A or A with B in vector addition, it is commutative. So next important basic law is the vector addition is associative. Let us see here. Vector addition is associative. Vector addition is associative. Okay. So I can write like this: A plus B plus C is equal to A plus B plus C. Here, ordered pair is not a matter. I have made the pair between A and B, and here I have made the pair between B and C. Let us see here how diagrammatically we can prove it. This is the point where at this point, suppose three forces are acting. This is the vector A, this is the vector B, this is the vector C. That means force is acting at this point in three different directions. Now, I shall find the B plus C. For example, B plus C. See that. Now, this is vector B. This C I am shifting here. This is vector C. Now, I mean using the triangle law of addition. So, definitely the resultant vector, this R will be equal to B plus C. So, the B and C, it is in order. B and C, it is in a order. Now the resultant vector, that is just in opposite order. Its tail is coincident with the tail of the first vector and head is coincident with the head of the second vector. So this is about the B plus C. Now with B plus C, I am going to add A. That means A plus B plus C. See that this A I am shifting to this point. This A I am going to shift this point. So this is the B. This is the okay. I can shift like this. Okay. You mention here, no problem. Now this is the vector A, this is the B plus C. This one is representing the two adjacent sides of a parallelogram. This is A. So I can say this is also A. I am shifting it parallel. So now this is the first vector A. With A I am adding B plus C. I am following the parallelogram method of addition. So in this case, this is one vector, this is another vector. So the resultant vector will be this one. So this is the resultant vector, which is the addition of a vector A with B plus C. This is the B plus C vector. This is the A vector. I am shifting it to this side. or you can imagine that this is a parallelogram. So I am following here parallelogram law of vector addition. So I can say that this resultant vector is equal to A plus B plus C. It is just like triangle law. I shifted this side to this one. Now I am following the triangle law. At first I made it two sides of the parallelogram. So parallelogram law says that we can shift this side to this side parallelly. There will be no change. So I got resultant vector R is equal to A plus B plus C. Now let us see this case. So this is the matter of a left side. Now we go to the right side. This is A, this is B. Now what I am doing, this is the vector A. Now I am shifting this B to this place. So I am shifting this B to here. This is vector B. Okay. So the A plus B, this is the resultant vector. What is this happening? This is A. Okay. This is the resultant vector. This is A plus B. Again, I have to add C with this result. So now C is here. I am shifting it parallel. Now it's shifted to this place. That means this is the vector C. So the resultant vector will be like this. This is the resultant vector. What I can write? A plus B plus C. You see that this one and this one represent looking like same. That means A plus B plus C whole is equal to A plus B whole plus C. So here pairing is not a matter. A may be paired with B or B may be paired with C or A may be paired with B. It does not matter. So here we found that this law is satisfied. I hope that you might have understood this concept clearly. So in my next video, I shall explain about the resolution of vectors. Until then, bye.